Hello, my name is Francesco Turco. I'm a technical advisor for WellTest here at F.A.S.T. Today we're going to have a look at conventional tests in WellTest. The workflow for conventional tests involves first importing and preparing the data for analysis. Then we enter in all of the PVT properties, fluid and reservoir properties. Then we move on to the diagnostic analysis, where we get our initial estimates for permeability, skin, and reservoir pressure. And in some cases, we're able to detect boundaries. Then we can use those estimates to create and refine a model and use that model to match our history of production. And we can also take that model forward and forecast. We have a number of conventional and non-conventional tests available to us in WellTest, and we have the WellTest wizard, which will help guide you through all of the different analysis techniques that we have available. Today we're going to have a look at a drawdown build-up test. Now the first step would be to import and prepare the data within the Data Management tab. And you can see I've already uploaded all of the data. We have our pressures and our rates in separate gauges. And we have a number of tools available to us for synchronizing our rates to our pressures, merging files if we had data in more than one file, smoothing any noisy data that we may have, and also filtering excess data that we don't need for analysis. Now, once we have all of that prepared, we transfer a copy of that data over to the production editor, which is a placeholder for the data that we're going to use in our diagnostic analysis. Next, we're asked to enter in all of our PVT properties. Now that we've imported and prepared all of our data and inputted all of our PVT properties, we're ready to do a diagnostic analysis on our derivative. So the diagnostic analysis lines with their characteristic slopes are listed here, and by selecting the appropriate line, in this case we see some radial flow, followed by what looks like linear channel flow. You can see we can get our initial estimates for permeability, skin, initial pressure, and if we use that initial estimate of permeability, we can get an estimate of our channel width. Now that we've got our initial parameter estimates from our diagnostic analysis, we can use those initial estimates to populate our model. I've created here a vertical wellbore model with a channel. And by clicking these little boxes, we can access the estimates we got from our diagnostic analysis. And the estimates give us a pretty good match right off the bat, but we can use some refinement. Now we have the ability to go in and change these values manually to get a better estimate. Or we can select values and even weight values and do an automatic parameter estimate on them. Once we're happy with the model that we have, looking at both how the model matches the derivative and how it matches the historical pressures, in this case very well, we can use that model to do forecasting. On this particular case, we have a 48-month forecast where we've flowed the well at 5 million a day at a bottom hole flowing pressure of 500 psi. Now we can also start playing around with some what-if scenarios, like if we had a bottom hole flowing pressure of 1,000 psi, or if we kept the bottom hole flowing pressure at 500, but did some stimulation to our well. And we can see how each of those will affect our production and rate going forward. There are a number of benefits associated with conventional tests. The first being that short-term tests provide critical reservoir parameter estimates for permeability, pressure, and skin. With longer-term testing, we're able to sometimes investigate boundaries. And using these parameter estimates, we can develop models that we can use to forecast production for multiple completion or operating strategies. And we can also use that to create any sort of what-if scenario. If you have any questions, please contact F.A.S.T. Thank you.